Alright, today on the bench we have a Mojotone 18 watt British amp kit. This was a recent build. When the owner completed it, he had problems with static and the amp cutting out. He tried to resolve the issue but couldn't. Sent it in, had it repaired, said it worked for a little while, and then he noticed that the amp would play, fade out. If he smacked it on the front panel, it would play again for a little while. So he's kind of tired of dealing with it. Sent it to D-Lab for evaluation. I've already looked it over, and of course the typical problems are there. Let me show you. Here's the bottom side of the amp. Pretty nice looking build, like the blue turret board. So since he said he smacked the front and it would start playing again, the first place I looked, of course, was front panel. And I spotted that typical ground runner soldered across the back of the pots. I thought, okay, let's take the old X-Acto knife and do a little lift test. See there? That solder is peeling right off the back of the pot. And this lug of the volume pot, which is the low side, is loose. See there? It's not even soldered. So all these connections across the back are problem generators. So what I'm going to do, like I do with the fenders, we're going to install a brass ground plate. So I'll lift these controls, slide the brass in, get it marked, drilled, and we'll bring all these ground points to the common brass ground plate. And that should resolve those issues. Then, I looked here at the turrets. Right there, you see that wire wrapped around? Well, I can actually spin that wire on the turret. It's loose there. And there's a couple others that I spotted. Then I looked at the filament circuit. So the filaments come from these runners off the power transformer. If you look down here on the back, I know it's super hard to see, but there's about a ½ inch of bare wire deathly close to this switch terminal. And if you look, you can see that this is oversized wire. And if you keep looking down, you'll see that there was some difficulty getting those wired up and having clearance. So I'm going to remove that 18 gauge wire and change out the preamp tube filaments with 22 gauge wire. I'll start by landing a terminal board here, and then we'll feed this tube and lace the twisted pairs tight against the chassis. We're going to start by installing the brass ground plate. So I need to cut this ground runner, loosen the hardware on the controls, recess those, slide in the plate, mark and drill it, and put it back together and reroute the grounds. So if you take a look, I was able just to take my X-Acto knife and pull that solder right off the back of the pot. Solder will not adhere properly to the case of these potentiometers, and even if you were to get it to solder, it's still a lousy ground because this little cap crimps on the pot, and then you're hoping that you make connection to that brass shaft that goes to the chassis. Using a direct ground is definitely the best thing to do. So watch, I simply take along those pliers and I can roll that ground runner right off the back of these pots. Alright, that ground runner is gone. Now it's time to retract these potentiometers, slide in the ground plate. But why go through this in the first place, guys? You can spend about $1 on a piece of 10 thousandths brass and you won't have to deal with this. Alright, there's the ground plate. Slide it into place, lines up nicely. Let's get the controls installed. Okay, I got the amp fired up. A lot of hiss, but if you turn the mid back, it goes away. Also noticed, if I bring this gain up, hear that? It's not a dirty pot, that's feedback, probably lead dressing. And I noticed that the first 12AX7 socket has a pin full of solder. So that happens if you solder these things upside down. You should always do it on the side so it can't roll up into the socket. So I'll probably be changing that too. Time to look at the wiring on those controls. Alright, we'll close up on the new ground plate. And we just got straight running wires which are next to each other, and that could be the reason for the feedback. So before I go any further with the filament wiring and changing sockets, I need to resolve this feedback issue. So I think I may have found the reason that we have the feedback and the excessive hiss on this input channel. So if you look at this jack, you'll see you have a ground side over here, but it's got 12 ohms. If you go over here, it is connected to chassis. And I looked at the diagram, there's supposed to be a jumper connecting these two grounds together, just like this side is. So let's make that change, see what happens. Alright, looking a little bit closer at this jack, there's a lot more going on than what it appeared. This 68K resistor, according to the diagram, should be up here on pin 7 of the first 12AX7 tube. If you look down there, see that little green wire? That's going all the way over here to ground this jack. So there's a bunch of stuff that's wrong here. I'm going to go ahead and rewire this and see how it goes. So I rewired the jacks, and they are now connected direct to the ground plate. The 68K resistor is supposed to go to pin 7. I simply raise that wire and put it in series. I just want to see if that nasty feedback's gone, and it is. It's still a good old hissy Marshall design, but now that channel will actually work. Coming along. Moving forward on the 18-watt amplifier rebuild. Now I'm inspecting the board and components, and I'm seeing that there are components that are not in the right positions. For example, in the power supply, you got this 2.7K that should go to a 10K, which it does, but then over here, that should have been another 10K, and the 2.7K should have been over here next to that electrolytic cap. Also, as I stated earlier, I need to replace one of the 9-pin sockets and rewire the filaments. Well, I was in here looking at how these are wired against the diagram. These 3 sockets are spun 180 degrees. So the wires that were supposed to go to the pins have also been flipped. For example, this cathode lead here should be going to pin 3, but since the socket's spun, it's on pin 8. So these 3 do not match the diagram, which is pretty confusing. So since I have to change that socket and rewire these filaments, I'm just going to go ahead, replace the socket, flip these, and get this thing in line so it'll be easier to work on in the future. So here's the 9-pin socket pulled from position 1. This is the one that has solder in one of these female pins. Okay, so the reason this happens is when you mount the tube socket and you're soldering, that solder will flow down into the upper portion, which it shouldn't. Once it gets in there, it can no longer grip the pin, and usually you can't even put in the 12AX7 without forcing it. The only way to repair that is to replace it. The way to stop that from happening in the future is to solder these with the amp on its side. So when you put your soldering iron on the terminal, it'll solder the wire, but it'll pull the solder towards the iron. Gravity won't be able to pull it down into the tube socket. So I'll be changing that with the others, and we'll go from there. I'm looking at the output tube sockets, and this one also has solder, and there's a damaged pin here. So I'm going to pull all the sockets and inspect them, see which ones can be saved and which ones I got to replace. So here we go. I've pretty much removed all of the tube sockets. I might be able to save 2 of them. The rest are in pretty bad shape. This one, you can actually see the pin popping out, so the restraint's not holding it anymore. I finished the filament wiring. This is silver Teflon 22 gauge wire, super high quality. Made another observation here. that I want to bring up to you guys. So here's one of the sockets that I removed from the amp. These look like Belton sockets. However, they are not. These are some copies of the Beltons. A real Belton will have a B stamped inside of the socket like you see here. I don't know what these are, but I bet you they're a cost save. Alright, next I need to land the wiring back onto the sockets per the print. However, I'm not going to use this gigantic wiring. We're going to go ahead and reduce all this to 22 gauge color code so it looks good and it's easy to work on. Well, I've completed the tube socket wiring using that nice silver Teflon wire. Sure looks a lot neater. Swapped around those resistors that were wrong on the power supply. So now the 2.7K is over here by that electrolytic. It's time to test. Alright, it's test time. Just powered up the amp. I have volume, master, and gain all the way down. Just want to listen to the noise floor of the amp. There's full volume. If I bring up master and the gain, not too bad. However, I can detect a little bit of 60 cycle hum in the gain channel, but not on the normal channel. So I've read a lot of reports online about this 18 watt build, and a lot of people are experiencing hum and hiss on the amps, and I believe it's this channel they're hearing it on. I'm not sure, but that's kind of what these amps are known for, is that super high gain. Alright, I'm going to pop in a signal. We'll make sure both channels play. So here is the normal gain channel, I guess you would call it. So that's playing well. Check out the Gainiac channel here with the master and gain. I'll bring up my master. Alright, so now I turned the gain all the way down, and you can hear a little bit of that 60 hertz. I did scope the power supply. They did not use a choke on this design, so there is some ripple, about 10 volts peak to peak, right off the main filter cap. I pulled the inverter tube out, and the hum obviously went away completely. So what we're hearing is not necessarily the power supply. It's probably a little bit of hum getting into the inverter and that high gain circuit. But I would call this amp okay to operate. She's loud.